Here we have the function f of x equal to x minus 1 to the 2/3, and this is what the graph looks like. And we want to find the critical numbers, and again, definition of critical number is that's where the derivative is equal to 0, and or the derivative is undefined or does not exist. And so we look at the graph, it looks like we have a minimum, it looks like it's the point 1, 0. And so let's find the critical numbers and see if it is 1, 0. And so to find critical numbers, find the derivative first and then set it equal to 0. So first we need the derivative right here. So here we have the function x minus 1 to the 2/3, and so we'll use the chain rule, and so we'll let u be x minus 1. And so the chain rule says first do the regular derivative, so we get 2/3, and then x minus 1, and then subtract 1 from the exponent, and then times the derivative of the what we call u, the x minus 1. And so that's the chain rule. So here we get 2/3, and then x minus 1, and then 2/3 minus 1 is negative 1/3. And then the derivative of x is 1, derivative of 1 is 0. And so here we just get 1. And so the derivative is just going to be 2/3 times x minus 1 to the negative 1/3. And then now to find the critical numbers, we set the derivative equal to 0 and solve for x. This is the same as 2/3, and then times, this is x minus 1 to the negative 1/3, so we can write that as 1 over x minus 1 to the positive 1/3. And then if we evaluate the derivative here at 1, then in the place of x we put 1, and then this will be 2 times 1 is 2, and then this is 1 minus 1, which is 0, and 3 times 0 is 0, and so this is undefined. And recall that the definition of a critical number is where the derivative is equal to 0, and also where the derivative is not differentiable, or in other words, where it's undefined. And so in this case, the derivative is undefined at 1, and so derivative so here we say is undefined at x equal to 1. And so we said that the function, the original function, f of x is not differentiable at x equal to 1. So if the derivative is undefined at some number, then we said that the function, the original function right here, the function x minus 1 to the 2/3, maybe let's go ahead and write that down. So we said that this function right here is not differentiable at x equal to 1, and therefore 1 is the critical number. And then, so that's how we find the critical numbers, is to check and see where the derivative function is undefined. And then the other way is set the derivative equal to 0. And so in this case, we would set this right here equal to 0 and see if we can solve for x, if possible. So here we would divide both sides by 2/3, or multiply both sides by 3/2. And so we get 1, this would be 1, and this is 0. This is equal to 0. And if then there's no way the 1 can ever be equal to 0. And so the only way that this quantity here can be 0 if the top is 0. But the top is always going to be 1. And therefore, this will never be equal to 0. And so, the only critical number that we have is just x equal to 1. And then if we look at the graph, we see that we have a 1 here. And we have this point right here, which is 1, 0. And so the only critical number that we have is just x equal to 1. And now let's find the corresponding y value. 1x is 1. So 1x is equal to 1, and then f of 1 is equal to this, which is equal to 0. So we have the point 1, 0. And then we can see here that we have a minimum right here. So we saw that the function right here, the function f of x, has a minimum at the point 1, 0. And the minimum is 0. And again, we look at the graph, and we see that the lowest that on the y-axis here, the lowest that the graph will go down to is when y is 0, and it doesn't go anywhere below that. And so that's why the minimum is 0. And so again, that's the minimum when the function f of x has the minimum at the point 1, 0, and the minimum is 0.